Welcome to the November 2024. This is the Edexcel paper 2, the first of the two calculator papers of the GCSE. Alright, question number 1. Push the numbers on your calculator in the correct order. 4.643069317 if you do it correctly. That is a positive correlation. And then for our line of best fit, make sure you get it through the points, draw a point up. I got 28 meters. Anything between 26.5 and 29.5 is absolutely fine for that one. Question 3, the chocky bars. We're comparing London and Zurich here. I've taken the London chocolate bar, times it by 1.25, so the London chocolate bar would cost 4.375 Swiss francs. Divide that by 200 and we get 0.021875 Swiss francs per gram. So that gives us an idea of how much the London chocolate bar costs. Then for the Zurich chocolate bar, we can divide our 7.2 by 360. It comes out as 0.02, which is slightly less Swiss francs per gram. And so we can conclude that the Zurich chocolate bar is better value for money than the London one. Okay, on to question 4. So we've got 17 in there twice. So you've got to remove 17 from the A intersect B complement, the bit that's only in A. And also 1 needs to go in there into the outside section. I've got the outside section A union B complement, but one in the outside would be fine. Question number 5, when x is negative 2, y is 5. When x is 0, y is negative 3, and negative 4, 0 and 5. Plotting the coordinates, so negative 2, 5, negative 1, 0, 0, negative 3, and so on. And then we've got to draw a line that passes through all of those within half a mini square of each one of those points. That was my best effort. Took me a few goes. I'm still not sure. I'm convinced it's that great, but that's what you're going to get. All right, question number 6. 85 minus 76 over 76 times 100. That's going to work out our the percentage increase in costs of the first class one, and for the second class one, that one came out as 11.8421. It's a percentage price increase. And then for second class, 65 to 66, so 66 minus 65 over 65 times 100, that's a 1.53846% increase. And then dividing the two percentage increases, 11.8421 divided by 1.53846 comes out as, most importantly, a number greater than 7. So therefore, Philip is correct, although I'm not sure that's quite how I would spell the word Philip. Question number 17, we've got an isosceles triangle here, so A to C and C to B will be equal in length. That allows us to construct an equation for the two lengths, so 2x plus 11 will be equal to 4x minus 4. Add 4 to both sides, subtract 2x on both sides, divide both sides by 2, x would be equal to 7.5. So our three lengths are going to be 26, substituting 7.5 into 2x plus 11. We know the other one's going to be 26 because of the way we constructed it, and the base 2x plus 5 is 20. To find the area, well, let's construct the perpendicular height here. So I'm going to split the base into two tens. The 10 on the right, we've got a 26 as the hypotenuse, and so using Pythagoras, we can find that perpendicular height, 26 squared minus 10 squared, and then square root it, comes out as 24. So the perpendicular height of the triangle is 24, and so a half times base times perpendicular height. Half times 20 times 24 gives us an area of 240 centimetres squared. Question 8, dividing both sides by 4 times 10 to the negative 20. We get k equals 1.25 times 10 to the negative 12 divided by 4 times 10 to the negative 20. Plug that in to a calculator, you'll get 3,125,000. In standard form, that's 3.125 times 10 to the 7. Question number 9. So we're dealing with nonagons. These are 9-sided shapes. Tells us they're regular, so we can use the formula for regular shapes. That would be n minus 2 times 180 over n, where n is 9. The interior angle of nonagon is 140 degrees. Impressive if you just knew that. If you have learnt those, there's no harm. Saves you a bit of time. Then we've got 2 of those 140s side by side around point B. So to find the angle inside the shape we're looking at, we can subtract the 240 from 360, and that gives us 80 degrees. That's enough for us to know that ABCD is not a square. Squares do not have 80-degree angles inside them. Question number 10, simultaneous equations. It's not much easier lining up x's compared to y's. Maybe it's marginally easier. You could have lined up the y's, that would be absolutely fine. I've done the x's times the top equation by 3, the bottom equation by 2, and then subtract the top equation from the bottom equation. Divide both sides by 29. When you've done that, y is negative 6. Then go back to any of the equations you have, substitute negative 6 in and solve it to find out the value of x. Comes out as negative 2.5. So x is negative 2.5, y is negative 6. You could have done that in quite a number of ways, and that would have worked fine. Alright. Here's me not quite drawing lines straight. We've got 3 lines drawn through the points that correspond with each other. They should meet exactly at a single centre of enlargement, but because I haven't drawn them well enough, I think the one of them, perhaps the bottom line, isn't good. Anyway, enlargement, scale factor 2/3, centre negative 4, negative 2. 3 marks. No, 2 marks. Question 12. So we've got 7.86 times pi times 3 squared times 8. That's going to give us 1777.89. And then divide that by 8.5 and cube root it. And we get the value of h, which is 5.9. Question 13. Those are not directly proportional. One of the things with direct proportion, if one is 0, the other would be 0. You can also show that 8 divided by 6 is not the same as 4 divided by 4. Or any combination of picking pairs of values and showing that we don't have a direct proportion set up here. Okay, for the w being directly proportional to the square root of t, so w is proportional to root t, turn that into an equation, w equals k root t. Substitute t to be 64, w to be 140, 140 will be equal to k times root 64. Root 64 is of course 8, so divide both sides by 8. K will be 140 over 8, which is 17.5. So our equation is going to be w equals 17.5 root t, and then if we substitute t to be 7.84, and we get w equals 17.5 times the square root of 7.84, which is 49. And a relationship there is going to look like a square root relationship. It has that sort of shape, passes through the origin and curves off like so. 10 football teams, so if there are 10 football teams, to work out the total number of games, you'd do one team plays 9, the next team plays 8, the next team plays 7 that are left, otherwise you're double counting, and then I'm timesing all of that by 4 because they each play each other 4 times, comes out as 180. Question 15 is a quadratic sequence. I'm going to call the quadratic sequence S, and that's S for sequence, so 3, 20, 47, 84, 131. The first difference between those, 17, 27, 37, 14, 7. So we don't have a common first difference, which is true for all quadratic sequences. Second difference is 10, 10, 10. So halve the 10 to get 5, and I'm going to write out the sequence of 5n squared. 5n squared, so 1 squared is 1 times 5 is 5, 2 squared is 4 times 5 is 20, 3 squared is 9 times 5 is 45, and so on. And I'm going to work out the difference between my sequence, not my sequence, the sequence given, and the sequence 5n squared. And it comes out as minus 20246, which is the 2 times table but shifted down 4 places. So the difference between our sequence and 5n squared is 2 times table, 2n, take away 4, shifted down 4 places. Add 5n squared to both sides of that equation, and our sequence is 5n squared plus 2n minus 4. There are other ways of doing quadratic sequences, that's just one of them. So iterative formula, so 4 equals k times 9 plus k. From that we can deduce that k must be equal to 0.4. To find the third term, we'll substitute 4 into it, so 0.4 times 4 plus 0.4, which comes out as 2, so u3 is 2. And for u4, substitute 2 into it, 0.4 times 2 plus 0.4 is 1.2. So u4, the fourth term, is going to be 1.2. Alright, for the histograms, we can work out the areas of the bars that we do have and then subtract them from 60. So the first bar's got a height of 2.2 and a width of 5. 2.2 times 5 is 11. We've got 15 and 6. Add those together, subtract them from 60, and that gives us 28. We know that those 28 are shared equally between the remaining 2 bars, so that's going to give us 14 in each of them. So the first bar's got a width of 5, so if I do 14 divided by 5 gives me the frequency density 2.8. The second one's got a width of 10, 14 divided by 10 is 1.4. And that's the height of the bars that we're going to have to draw. So you get your ruler, that bar's of height 2.8, and then that bar is of height 1.4. There we go. Alright, question 17. We've got to find the common denominator. Both 2x and 5xy are factors of 10xy, so let's write these as fractions over 10xy. I don't need to change the first one. The second one, I can multiply the top and bottom by 5y. And the last one, I'm going to multiply the top and the bottom by 2, and if you spot a mistake here, yes, I know that should be a 10xy as the denominator. I forgot to multiply the denominator by 5. However, I've corrected my mistake because I know I've got a common denominator of 10xy now, and I've added together the numerators to get 20x. The denominator is 10xy, and that all simplifies down to 2 over y. Okay, the geometric proof question. There's a couple of ways of doing this one. I have done it using congruent triangles. We're going to show that BAO and BOC are congruent. If we do that, then they're both congruent isosceles triangles, so the base angles will be equal to each other, and therefore BO will bisect the two others. Now, so congruency, side, 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 I'm going for. So BO is equal to BO because it's the same side. BA is equal to BC. It tells us that in the equation. Sorry, in the question. And lastly, OA is equal to OC. That is because both of those lengths are radii. So therefore we can conclude that triangles ABO and triangle BOC, we can conclude that they are congruent because of the side, side, side criterion. And therefore angle ABO must be equal to angle OBC. OB must bisect angle ABC. Question number 19 is the upper and lower bounds. So W, correct to the nearest 5, it's going to be 437.5 or 432.5 for the upper and lower bounds. A rounded to 2 sig figs, so that's 9.85 or 9.75. And C also rounded to 2 sig figs. It's going to be 2.55 or 2.45. Another mistake in there. Well done if you spotted that one first. Alright, so the upper bound for T, we want W to be as big as possible, and we want to divide by something as small as possible. So I'm going to take the lower bound of A, and I'm going to subtract the upper bound of C. Fortunately for the upper bound of C, I've used 2.55. So that comes out to 60.76, etc., etc. For the lower bound of T, we're reversing all three of those, so I want W to be as small as possible, because that's going to keep T as small as possible. I'm going to divide by as big as possible, so we're going to divide by the upper bound of A, but take away the lower bound of C, so 432.5 all over 9.85 minus 2.45. Comes out as 58.4, etc., etc., etc. So now I'm looking at those two, we've got to round that to, what do they both round to? Well, one significant figure is all that they round to in common, so they're going to round to 60. So 60 is my answer. Okay, for 20, a bit of 3D geometry. I'm going to draw the height from V to F. We know that C to F to F to C to F to F to M is 2 to 1. We've got a 60-degree angle in there and a 52-degree angle inside the shape. and we know the height is 8. Okay, so tan of 52 will be the opposite over the adjacent, so it will be equal to 8 over f to c. Rearrange that and we can find f to c. I'm not going to calculate it, I'm going to leave it as an exact answer. If you have calculated it, that's absolutely fine. Doing trig on different triangles, sine of 60 will be equal to the opposite, which is f to c times by 1.5, because c to f to m is 2 to 1. So if you take c to f and times it by 1.5, you'll get c to m. That's the opposite. That will be, sine of 60 would be that over a to c. Quick rearrangement of that to make a to c the subject, times by a to c divided by sine 60. And then that I can plug into my calculator and get an exact value. If you've calculated them part way through, that's fine, as long as your answer ends up as 10.8 to 1 decimal place. Question 21, so we've got P, R and Q. And we're given P and Q. A little sketch here can help us. It's not a very good sketch, I know. Hopefully you can put up with that fact. There's my point R, where those two meet. They meet at right angles, means the two lines are perpendicular to each other. R is k plus 3. Perpendicular lines, whenever we have perpendicular lines, the product of their gradients will be -1. So we're going to use that fact. P to R, so it's y2 minus y1 over x2 minus x1, or k plus 3 minus 5 over k subtract -4. Simplifies to k minus 2 over k plus 4. The gradient of q to r, again same formula, y2 minus y1 over x2 minus x1. We'll get k plus 3 subtract -6 all over k take away 6. Simplifies to k plus 9 over k minus 6. Now, using the fact that the product of perpendicular gradients is -1, I take those two gradients, multiply them together, and equate it to -1. This is the equation we need to solve to find the values of k. Multiplying two fractions, multiply their numerators, multiply their denominators. Actually multiply both sides by the denominator here, just to get rid of the fractions. And then start expanding everything out. K squared plus 7k minus 18 will be equal to -1 lot of k squared minus 2k minus 24. Expanding out the right hand side again. And then we got a quadratic, we need it to be equal to 0, so I'm going to bring everything onto the left hand side to keep the coefficient of k squared positive. So 2k squared plus 5k minus 42 equals 0 is our quadratic. That one factorizes quite nicely. If you use a formula, then of course that's absolutely fine. But 2k minus 7k plus 6 equals 0, so k is equal to 7 over 2, or is equal to -6. Question 22 is quite a tricky one, this one. I have decided to label R as the number of red counters and Y as the number of yellow counters. It tells us in the question that 3/5 of the counters are red, so R out of the R plus Y counters must be equal to 3/5. Doing a quick rearrangement of that, times both sides by R plus Y, times both sides by 5, and then just rearrange a little bit, we get R equals 3 over 2 lots of Y, and that's a useful little substitution. Then 2 red counters in a row. Well, the first red counter, we know there's a 3/5 chance of it being red, times by the second red counter, it's going to be 1 less red counter, R minus 1, all over R plus Y minus 1. Then 2 yellows in a row, 2/5 times y minus 1 over r plus y minus 1 is equal to 41 over 80. It is possible to do lots of substitutions before then. You'd end up with something slightly simpler. I'm going to do all the substitutions now. So all the r's that are there, I'm now going to replace with 3 over 2 lots of y. And now we get everything in terms of y. The question wants us to find the number of yellow counters in the box. So if we write everything in terms of y, that will help us do it. Then next line, again, I'm just simplifying denominators here. If you've got 3 over 2y plus y, it's 1.5 y's plus y's gives you 2.5 y's. So next line, I'm thinking about the initial fractions. I'm actually going to multiply everything by 5, and that gets rid of the denominator of 5 from the two left-hand side expressions. And then I'm going to expand out the numerators. So that first fraction there is 3 lots of 3 over 2y minus 1 expanded. The denominator is unchanged. Similarly, the second fraction, that's 2 lots of y minus 1, so 2y minus 2, the denominator is unchanged, and then multiplying by the 5 gives us 41, the 5 can cancel with the 80 to make 16. Now, we have a common denominator and two fractions added together, so I'm going to add the numerators. 4.5 plus 2 is 6.5, or 13 over 2. And that's equal to 41 over 16. Then I'm going to multiply both sides by 5 over 2y minus 1 and by 16. And we can expand those single brackets out. So 104y minus 80 equals 205 over 2 lots of y minus 41. Bring the y's onto the left, bring the non-y's onto the right, we get 1.5y equals 39, and therefore we can conclude that y must be equal to 26. 26 yellow counters in the box. Well done if you got that one. Bye.